Hello and welcome to this quick introductory tutorial on 3GPP. It has been years since we began a tutorial on this topic but never managed to complete it. As we are starting to move to 5.5G and 6G in the next few years, we thought it's a good time to explain 3GPP and how it works. So let's start by asking a simple question. Who or what is 3GPP? 3GPP is the third generation partnership project. During the days of the first and second generation of mobile technology standards, there were too many standards, generally one for a specific country or a region. So GSM was the standard from ETSI and was designed mainly for Europe. AMPS and DMS was designed mainly for the US and North America. There was a Japanese standard and some European countries had their own standards. This became too much of a challenge as the manufacturers of equipment and devices could not achieve economy of scale and bring the prices down. This led to the creation of 3GPP to create a single global standard. The question people often ask is, did 3GPP succeed in creating a single global standard? Initially, it didn't, but then it did, and we will discuss this later. 3GPP officially started in December 1998 with the aim to create 3G specifications and standards based on ITU's IMT-2000 vision. IMT-2000 was earlier known as Future Public Land Mobile Telecommunications System or FPLMTS. As you can see in the picture, before 3GPP officially started working on 3G, there were lots of ambitious visions that the industry thought could be achieved by data rates as low as 144 kbps. Little did anyone know about how iPhone and then Android phones would change the world. 3GPP brings together 7 telecommunications standard development organizations or SDOs, which are also known as organizational partners, and provides their members with a stable environment to produce the reports and specifications that define the 3GPP system. These technical specifications are then transposed by the organizational partners into their appropriate deliverables and standards. Here are the 7 organizational partners of 3GPP. Going from top left to bottom right, we have ARIB from Japan, ATIS from USA, CCSA from China, ETSI representing Europe, TSDSI from India, TTA from Korea, and TTC from Japan. So an important point worth highlighting again here is that 3GPP creates specifications which are not standards and have no legal standing. One or more organizational partners transposes them into standards. Here is an example of how 3GPP TS 38.331 is transposed by ETSI as TS 138.331 standard and by ARIB as STD T120 38.331 standard. Let us now look at the 3GPP ecosystem. As we discussed earlier, the 3GPP organizational partners are the 7 standards developing organizations from China, Europe, India, Japan, Korea, and United States. Participation in 3GPP is made possible by companies and organizations becoming individual members (IM) of one of these operational partners. Specific inputs in the form of market requirements may also come into the project via any of the 20 or so market representation partners in 3GPP. These organizations have all signed up to the 3GPP project scope and objective. Lots of external cooperation with other standards bodies and a broad variety of other groups by way of formal liaisons. This slide shows some of the 3GPP market representation partners. This is a slightly older slide from 3GPP. Surely there are more MRPs now. This is a non-exhaustive list shared by 3GPP of different verticals, operators and vendors which attended September 2019 3GPP plenaries. One of the main drivers for 5G was the private networks. The fact that so many verticals are engaged with 3GPP allows them to input their requirements, and as a result the standards could be more relevant to all these verticals. We have a good tutorial on private networks, so please do check it out. We often get asked about how one can become a member of 3GPP. Individuals cannot become 3GPP members, only organizations can. These organizations could be many different types like private or public companies, governmental organizations, educational institutions, universities, etc. There is no direct membership to 3GPP as it is a partnership project. The delegates come to 3GPP via their organization's membership of one of the 7 3GPP organizational partners. The organization that joins 3GPP becomes an individual member. An organization can be full individual members, observers, and guests. Here is a simplified chart that shows the major mobile cellular standards. You may remember that in the beginning I mentioned that 3GPP did not initially succeed in establishing a single common worldwide standard, especially in 3G days, but it was successful in bringing together many different companies and organizations. This allowed its 4G standard, also known as LTE, to become a single common standard for all mobile cellular networks. In fact, when 5G was being specified, there was no need to call it by any other name because there is no other challenging standard remaining. Sometimes we get asked if 3GPP will ever change its name. The answer is no, because there is no need. The industry understands what 3GPP is. There is no need to confuse everyone by rebranding it. Let us now look at the different generations of 3GPP technology. As you will notice, what we call as 3G was standardized as IMT-2000 by the ITU. 4G from 3GPP was LTE-Advanced and standardized by ITU as IMT-Advanced. Finally, the fifth generation or 5G technology was specified as 5G by 3GPP and standardized as IMT-2020 by the ITU. I wanted to show this IMT-Advanced Venn diagram, which was in the ITU recommendation specifying the objectives for the future development of IMT-2000 and the systems beyond IMT-2000. Similarly, for 5G, you must have seen the IMT 2020 requirements triangle as specified by the ITU. The whole process of defining standards from ITU's point of view starts with technology trends, followed by vision document, performance requirements, evaluation criteria, submission templates, proposals, evaluation, outcome, and specifications. Even though the diagram talks about IMT 2020 or 5G, the list of documents shown is mostly to do with IMT Advanced. Nevertheless, it is a good diagram showing the flow of ITUR standardization for each generation of technology. Let's understand this from the 3GPP point of view for 5G specifications. World Radio Conference or WRC 2015 defined the spectrum under 6 GHz that can be used for 5G as well as study items for mmWave spectrum. These studies concluded with WRC 2019 where ITU announced a list of mmWave spectrum available for IMT or mobile communications. ITUR also defined the requirements for the next generation of IMT technology beyond IMT-Advanced, known as IMT 2020. 3GPP took all these and defined the next generation of mobile standards, which it called as 5G. 5G comes in two different flavors. The first one is called SRIT in ITU terminology or non-standalone in 3GPP terminology. The second one is called NR-RIT in ITUR terminology or standalone in 3GPP terminology. RIT stands for Radio Interface Technology and SRIT is set of radio interface technologies. As you are no doubt aware, SRIT or non-standalone has both 5G NR as well as LTE components, as can be seen in the diagram. 3GPP had to submit lots of documentation for 5G to be considered an IMT 2020 technology. This is a summary of all the documents submitted to ITUR. Based on the 3GPP submissions, 5G became an IMT 2020 technology. As can be seen in the picture, there are two flavors, 5G SRIT and 5G RIT, which we discussed before. This is the 3GPP release timeline all the way from 3G in release 99 all the way up until release 21, which is when the first version of 6G is supposed to be standardized. Now let's look at how 3GPP is organized and also look at the 3GPP releases process. Let's start with Project Coordination Group or PCG. The PCG is the highest decision-making body in 3GPP. It meets formally every 6 months to carry out the final adoption of 3GPP Technical Specification Group work items to ratify election results and the resources committed to 3GPP. The organizational partners coordinate the working of 3GPP through PCG. PCG is responsible for overall time frame and management of technical work to ensure that the 3GPP specifications are produced in a timely manner as required by the marketplace according to the principles and rules contained in the project reference documentation. We can show the scope of PCG as covering core networks, RAN and terminals. PCG is responsible for appointment of chairs for PCG as well as the technical specification groups or TSGs. There are three different TSGs as can be seen covering different aspects of 3GPP system and process. The 3GPP TSG RAN is responsible for the technical coordination of the specification work done in radio access part of 2G, 3G, 4G and 5G. So this covers GRAN, UTRAN, EUTRAN, NGRAN and even beyond. As you can see, there are 6 different work groups or WGs. RAN WG1 or RAN1 or R1 is responsible for layer 1 or physical layer. RAN2 is responsible for layer 2 and layer 3 of radio. So this includes MAC, RLC, PDCP, SDAP and RRC. RAN3 is responsible for RAN architecture and related network interfaces. RAN4 is responsible for radio performance and protocol aspects. RAN5 is responsible for mobile terminal conformance testing. RAN6 was responsible for GSM and Edge RAN, but it is no longer active as there are no 2G RAN changes. 3GPP TSG core networks and terminals is responsible for the technical coordination of the specification work on terminal interfaces which contain both the logical and physical and smart card application aspects, user equipment to core network protocols, interworking with external networks, core network protocols of 3GPP systems. Currently, CT specifying protocols and APIs related to the 5G system, including the IP Multimedia System or IMS, the support of vertical industry services like mission critical services, industrial IoT, automotive, etc., and interworking with edge computing networks. There are four different active work groups as can be seen. CT, WG1 or CT1 is responsible for user equipment and core network protocols like mobility management, call control, session management, etc. CT3 is responsible for interworking with external networks and policy and charging control. CT4 is responsible for core network protocols like mobile application part, GPRS tunneling protocol, broadcast channel, supplementary services, etc. CT6 is responsible for smart card application aspects like SIM, USIM, iSIM, and a lot more. CT6 is doing a lot of interesting work currently on evolution of USIM application for securely accessing 5G networks over 3GPP and non-3GPP access uh, by providing user privacy, by concealing the user's identity in 5G networks, supporting configuration capabilities for 5G services, example steering of roaming, V2X, wireless wireline convergence, multi-device, multi-identity, and a lot more things. Finally, we have the 3GPP TSG service and system aspects or SA, which is responsible for the overall architecture and service capabilities of systems based on 3GPP specifications. Consequently, 3GPP TSG SA is responsible for the cross 3GPP TSG coordination. Some of the tasks TSG SA is currently responsible for includes overall development, coordination and evolution of 5G and LTE technologies, overall coordination between 3GPP TSGs and 3GPP SA working groups, service and feature requirements, architecture of the 3GPP core network and the overall 3GPP system, security and privacy of the 3GPP system, codecs and their transport, multicast broadcast streaming and real-time communication, management and orchestration of 3GPP system components, charging, enablers for vertical applications and general 3GPP services, and a lot more things. You can see there are 6 active work groups in SA. SA1 is responsible for services, SA2 for system architecture and services, SA3 is security and privacy, SA4 is multimedia codecs, systems and services, SA5 is management, orchestration and charging, and finally SA6 is application enablement and critical communication applications. This is a combined view of responsibilities of different TSGs within 3GPP. A few more things about the 3GPP organization. TSGs meet 4 times a year in the so-called plenary meetings, which are co-located. Work groups meet once or more per plenary cycle, generally not co-located. Each TSG and each work group elects its own leadership for 2-year terms and a maximum of 2 terms for any elected official. Technical work is mostly done in work groups. Overall planning and coordination in TSGs. In 3GPP, the work is organized as study item or SI and work item or WI. A study item is, as the name implies, a study of a feature or impact of bands, band combinations, changes or anything else. The end result is a technical report or a TR. Work items on the other hand is again a feature or a change that will eventually become part of technical specifications or TS. Releases have fixed timelines that are partially overlapping. 3GPP portal has an online work plan which is a great place to start. Let us look at a video of work plan.
Okay, so we are testing here and I'm going to now open the work plan. So when you have this work plan, actually by default 3GPP portal opens the meeting section. You go on the work plan and here you can see all the different things. So you can search for different acronyms, different features, right? So let's start by searching something from maybe release 18. So I'm going to say search NTN. Okay, so these are the first level features from release 18 for anything related to NTN. But what you might want is you might want more detailed data. So you can say like let's say up to work task. Okay, so third level. So if I click on search, then here you have a lot more details and you can actually click on these different work items and look at the details, right? So this is all uh, the documents. Similarly, if you wanted to search this feature across all releases, so instead of you can say like search across all releases, but you can understand there is too much information, so it's going to search all the way from like the reverse order. So release 16, what was there as part of release 16, what was introduced as part of release 17, and then release 18. And you have all the documents associated with different releases. So you can go into as much detail as you want, and if you want to go even further, you can go all the way up to the fifth level, right? It will also give you the completion rate, when is the end date planned for a particular thing. um, so release 18, so of course this doesn't look right. It shouldn't be 2016, but yeah, you have all the different information here.
During a release, there are three stages and they are often overlapping. Stage 1 is requirements, stage 2 is architecture, and finally stage 3 is protocols. This is a very simplified high-level essay view on stage 1, 2 and 3 of a release. Stage 1 is the gathering of requirements by TSG, SA, WG1 or SA1 for short. Stage 2 is feeding these requirements to different assay groups and RAN. Stage 3 is feeding the requirements as well as all the information from different assay groups to the core network and terminals group for protocols and coding. Here is a simplified view of a release. As you will notice, while the requirements phase or stage 1 is ongoing, stage 2 or the architecture work has already started. Similarly, stage 3 work starts before stage 2 work is completed or frozen. Once the stage 3 work is completed, the whole release is frozen. Generally, after around 3 months, the code is frozen and ASN.1 is available. If there are any issues identified with this release, a change request or a CR will have to be raised and the document or code fixed in the next quarterly update. This is the same release view from 3GPP of release 18, which is expected to be completed in June 2024. Here is a summary of 3GPP on a single slide. We discuss some of these things during this presentation and some others we haven't. The last 2 points are worth emphasizing again, that 3GPP is contributions driven and consensus based. They are the main reasons for the success of 3GPP being able to create a single global standard for 4G and 5G. These are some references we used in this presentation. You can download these slides from our SlideShare channel as well as from 3g4g.co.uk. Hope you found this quick introduction to 3GPP useful. There are so many more topics we could have covered, but in the interest of time, we only highlighted what we consider the most important things worth knowing for everyone. Please visit the 3GPP website to learn more and find any other information you are looking for. If you found this video useful, please like, subscribe to our channel and let us know your thoughts. Thanks and see you again soon.